Hello everyone, this is Farooq here. Today we are gonna write a LED driver from register level. I'm using an STM32F446RET6 Nucleo card. So firstly you have to open the reference manual if you wanna write on STM register level. You will have to look really carefully in this datasheet. So let's start to write. Actually, I just wrote the both of them, but the button driver we are gonna write again just to show you, and I'm gonna explain what we are doing, why we wrote that, and where it comes from that. And let me show you the first. So on STM32F446, it's and the green LED it's pin PA5. So for the pin, first we have to set the clock. First we have to set the clock for the LED for the output. So let's get into reference manual, and then we have to look for the reset and clock RCC, reset and clock control, and we are working on registers, so we have to go there, the RCC register. So we are gonna enable the PA5 clock, so we have to find the enable this one. It's a AHB1 parallel clock enable register, and we are working on GPIO, so we have to make a 1, and let's get down. As you can see, bit 0 on this register. If you put 1 on bit 0, it's IO port A clock enabled, so we have to make this 1. So because of that, on this line we enable the GPIO clock to make this 0 bit. In this bit 0 bit we send them 1, so we make 1 to this register. We enable the clock. So after that, for GPIO we have to go to GPIO registers. Sorry. So let's close it. General purpose input output. We put that, and we have to go to GPIO register. So this is the mother. What is the mother? As you can see, if you put, there is a 32 bit. If you put 00, the pin is input, but we are PA5 is LED and it's output, so we have to make output, and it's on fifth one, the mother 5, because we are using PA5. So we have to put this. We are using the 01 general purpose output mode. It's our mode, and it should be 01. I mean this one, because we are using PA5. So 11th one should be 0 and 10th one should be 1, because we want to work on general purpose output mode. So that's why we put the 10th bit 1, and that's right, and set the 11th bit. Before we can go back. So 11th bit we have to put 0, right? So 11 bit we put 0. If you don't know anything about C language and on bit level, and or let me you can easily also use this one, but I'm using the bit level programmer. Yeah, as you know, we put 11th bit is 0, 8, 9, 10, and 11. We made 0, and 10th we made 1. So actually we can write that just 400 and in Excel uh, number, but I'm just prefer to use this one. Actually it means we slide 1 to 11, we slide 1 to the left 11 times, so actually it goes there to there, so it's there, and then we may not, and it goes 0 and we end it. Instead this to 10, this is a 10 bit, we slide left side 1 10 times, and then this number consists. So you can also use this one. I'm using the binary level, and if you want you can use decimal, hexal, whatever you want. But to teach you, I think the binary level is better. So that's why I use like this. I write like binary level, and let's get the manual, yes, general what, and let's get down the typer. What is the typer? Actually, it's mostly about electronics. So you choose this pin is push pull or open drain output. So for LED, the push pull is better. That's why we put 0. We should put 0 to, as you know, we are using PA5. We are gonna put there to 0. So we wrote this line just for this wrote that push pull, and hit down, yes, speed. So for GPIO output, we have to select the speed of the output. So if you are using like if you wanna make this really fast, if you need really fast like reaction, you can use high speed, but it's gonna be more less precise, I think. But I mean, it doesn't matter in here because we are just blink LED. So I just use the low speed, doesn't matter for me. So, and I just use 00, but to where, I forget, to 00, we are using PA5, that's why we use 11th and 10th bit. I will put 00. So as you can see, it's not, actually I wrote wrong here. I want to put 0 also the 10th bit. Let's write together. Sorry. Yes. Yeah, now it's right. I put 0 and 0, the 10th, 11 and 10th pin, I put 0, 0. So it's gonna be low speed, right? And let's write the button pin together. So again, we have to first enable to clock register. We go to RCC register, HB, where is the enabled register? This is the enabled register. So the on STM32F446, the Nucleo card, and the button is default is C13, I think. I don't forget. So we have to enable to C clock. So this one is here is 2. Yeah, C to bit 2 we have to put 1. Right. Let's, as you can see, bit 2 I put 1 to enable clock. Enable clock for input. That's right, input. Oh, but and now we have to set the C13 GPIO registers and mode registers. So I'm using and PC13, right? It's default button, so it's there. It's 27 and 26. But I want to use this as a button, so it's an input. I'm taking an input from outside. So and 27 and 26, it should be 0 0. So let's get in the code. So as you can see, let's write the 10th bit is not 1, it's 0, and set the 11th bit to 0, right? Both of them 0. So for input, we are not gonna use the type because it's for output, as you can see. So output type register. This is output speed register. I'm not using that. This is a pull up and pull down register actually. And when you look at the datasheet of this card, there is already a pull up, pull down. I think is pull up resistor. So we are not gonna use. We can just write 0 0 there because there is already they put already in it. So because of the pull up and pull down resistor, this resistor I have to use 0 0. So as you can see there, I just wrote this one in on decimal, right? 3. But let's write that. Let's write in our way to not to get confused. I don't want to confuse your mind. Let's write a 1 1 and 1, and which pins, as you can see, I'm using PC13, so 26 and 27 is gonna be 0. Yeah, that's right. These lines is for button, and these ones for LED. This one for LED, and this was for button. And in this video, I want to make like when I push the button and the LED is on. I want to make this one. So for this, we have to go to input data register. And let's get input data register. This is the input data register. We are going to read you can see the R means you can just read. But for example, it's RW, it means you can readable. It means this pin is readable and writable. So you can read and write. But I'm just gonna read the bit if it's 1, so the button is 1, the LED is on, and if it's 0, the LED will be turn off. That is on. So for that, we can use GPIO input data register. So we put that input data register, and we have to read this 13 because the button is in PC 13, as I said before. So we use AND operator. So actually, in this line, we read the 13, the bit. So we AND. Just think AND operator. If is 1, and when you 1 and 1, it's gonna be 1, right? If it's 0, here is always 1, this line. But we are gonna just check this one. If it's 1, it's gonna be 1. If it's 0, it's gonna be 0. So if we push the button, it's gonna be 1. Let's say 1. We push button and this line is 1. And this line is also 1. So it's gonna be, it will be turned on, right? The LED will be on. So in this statement, actually, we just thought that if this line is 0, 0, it's gonna be, LED will be on. So we put the output data register. Let's also show this one. Output register, we're using PA, forget the LED, PA5, yeah, PA5 for the LED. As you can see, this is readable and writable. We have to put 1 there. It is also written that this can be written. So we just send 1 and to open LED, turn on the LED, turn off the LED. So actually this line is kind of confused. For me also sometimes confused. So actually when you open datasheet, when you see that when you push the button, it goes to ground, so it makes 0. So when we push the button, this is gonna be 0, right? So this is 1. So 0, 1 here would be 0, and 0 if equals to 0 is gonna be 1. So if 1, we turn on the LED. But if you don't push the button, it's gonna be 1 with, because it's in the datasheet, as I said, it's connected to the VCC with pull up resistor. So when we don't push the button, this one will stay 1. So this is also 1. So when we add this with the 1, these zeros will be 1. So 1 equals to 0? No. So the turn off the LED. So the LED will be turned off. I hope you understand, and I will put the uh, image of the schematic. You will see that you will understand more better, I think, when I put the image. So I hope you understand, and thanks for watching the video. See you in the next video. Take care.
Hello guys, this is the application. As you can see,